Hi everyone, welcome to Resource Tutoring, Math 2011, 2012, and 2014, the engineering maths, and this are my contacts. If ever you find anything you don't understand, you can send me an email and I'll deal with that. Okay. This video I will be working on roots and polynomial, a section on algebra. A section on algebra. Okay, now we did ULS formula, we did complex numbers, and then roots and polynomials is actually trying to find the roots of complex numbers. Okay, and now what we really want to show that is that for a complex number has n nth roots for every natural number n. Okay, what we want to show is that for a complex number, for a complex number, and let's call that complex number a, it has n nth roots for every natural number n. Okay, now if from remember from when we were studying ULS formula, we said that e to the power of I theta is the same as r cos theta plus I sine theta. Okay, and now again from Taylor's formula, if you were to write a complex number a, we can write it as we did not have this. We can write a as a, which is a complex number, is equals to r e to the power of I theta. This is how we defined a complex number. Now what we did again was that e to the power of I pi over 2 is equals to I. Okay, and then e to the power of I pi is equals to minus 1, and then e to the power of I 2 pi is equals to 1. All this section here was covered in Euler's formula. Now I want you to take a good note of this, because what we are going to do here is very important. We are going to, it's going to seem like we are adding a new term to this definition, but we won't be doing anything. Okay, now I'm going to do this. If I'm going to say if a is equals to r e to the power of I theta, then a is equals to r e to the power of I theta plus 2k I pi. Yeah, I know you're definitely wondering from where did Lesotho get this? But if you are to check, this is what we did here. We took this. We took this and put it here, and we want to make sure that it's a multiple of 2 by putting k here, because if k is 1, it's going to be 2. If k is 2, it's going to be 4. So you can see that it's a multiple. It gives a multiples of 2. So what we did was that this is what we did actually. We want to say a. We said a is equals to r to the power of I theta, but because we want to simplify matters for ourselves, here shouldn't be this. Oh, sorry, here it is a is equals to r e to the power of I theta, and because we want to simplify ourselves to be able to work with roots and polynomials, we're gonna multiply this. We're gonna multiply this thing by 1, and which is that one? It's here. We multiply this by e to the power of 2 pi I. But it's not, this thing does not only contain this, it contains all the multiples of 2, and then we put k. Okay, this is where we came from, and then this is the same as, remember from our laws, from previous laws which were covered in grade 8 or something. We have two bases which are the same. Bases which are the same, we add the exponents, and thus it gives us this as r e to the power of I theta plus 2 k I pi. This is where this thing came from. It came from all this. Came from this part here, which is part here. We just multiply by 1, and then that's it. We did not change anything. And then this is what it is. Okay, and then we let me move to the next page. This is the end of the page here. Okay, and then now when we want to find the nth root of a being given as this. Okay, let me try to, now this is our a here, this is our a here in the in that box. When we want to find the nth root of a, that will be a to the power of 1 over n, which is the nth root, is equals to r e to the power of I theta plus 2 k I pi, close bracket, to the power of 1 over n. Everything is raised to the nth root here. Okay, now let's simplify this. This thing simplifies to r to the power of 1 over n, and then e to the power of I theta over n multiplied by e to the power of 2 pi ki. I'm so sorry that I'm mixing. I'm writing 2 ki pi, and then here I'm writing 2 pi ki, but the fact that I'm writing everything is here is what matters, and the fact that I'm multiplying it does not matter. The fact that everything is here is really what matters. Okay, now we're going to divide this by n. Okay, note that I just multiply everything here by n, and then I got this. Okay, now here k, this k here can be any integer, but by increasing k by n. When we increase k by n, the argument of a to the power of 1 over n, which is the nth root of a, increases by 2 pi. That is, when we increase k by n, when we say when we increase k by n, when you increase k by n, the argument of a to the power of 1 over n increases by 2 pi. Note that when something increases by 2 pi, it does not change. Like, say we have a circle, and then we have a point here. If we were to say plus or minus 2 pi, is either it's gonna be, we're gonna move this direction and then we're gonna end at the same point, or this direction we're gonna end at the same point. So if it increases at the same point, it defines the same value of the nth root. It defines the same value as the nth root. Okay, and then the different roots can thus be found by taking any n successive values of k. Now the nth root can be found by taking any, check this out, any, but there's a condition, any successive values of k, meaning that we can take k to be any values which are successive. It can be 0, plus or minus 1, plus or minus 2. Now to check this out, that this thing is successive, if you were to draw a number line, and then here we have 0, we have 1, we have 2, we have minus 1, we have minus 2. Note that these are successive. Minus 2, minus 1, 0, 1, 2, successive numbers. Or you can take 100, 101, 102. It's up to you, as long as you make your life easier. But this one is advised, because you don't have to multiply bigger values and all that. Okay, so basically this video was just to do the introduction of roots and polynomials, and then the next video I will be doing examples tutorial. I'll be covering tutorial 37. If time allows me, I'll try to do the whole of them. Yeah, so check out for the next video on roots and polynomial. Thank you for watching. Enjoy your day.